Question 1. Which approach would be the most effective and compliant for a certified auto technician to retrieve diagnostic trouble codes, DTC, and live data from a 2023 model year vehicle for emissions-related diagnostics, adhering strictly to U.S. regulatory frameworks for automotive repair? Option A. Utilize a diagnostic scan tool that is compliant with SAE J1979 standards for diagnostic services and supports the vehicle's communication protocols, such as ISO 15765 for CAN bus. Option B. Attempt to access the vehicle's internal network using a custom-built interface and proprietary software developed by the technician. Option C. Connect to the vehicle's infotainment system's diagnostic port and attempt to extract data through its user interface. Option D. Rely solely on a generic OBD-ROMAN2 code reader that only displays DTCs without providing live data or supporting specific diagnostic services. Correct answer is A. Utilize a diagnostic scan tool that is compliant with SAE J1979 standards for diagnostic services and supports the vehicle's communication protocols, such as ISO 15765 for CAN bus. Explanation. This scenario is professionally challenging because ensuring accurate and secure data communication is paramount for vehicle diagnostics, repair, and safety. Technicians must not only understand the technical aspects of data protocols, but also adhere to the regulatory framework governing automotive data, which in the U.S. is primarily driven by the EPA's onboard diagnostics, OBD, regulations, and related industry standards. The challenge lies in selecting the most appropriate and compliant method for data retrieval and interpretation in a real-world repair environment, balancing efficiency with regulatory adherence. The correct approach involves utilizing a diagnostic tool that is specifically designed and certified to communicate with the vehicle's OBD-ROMAN2 system, adhering to the SAE J1979 standard for diagnostic services. This ensures that the data retrieved is accurate, interpretable, and compliant with emissions-related diagnostic requirements mandated by the EPA. This method is correct because it directly aligns with the regulatory framework that requires standardized communication for emissions-related diagnostics, ensuring that technicians can accurately identify faults and perform necessary repairs without compromising environmental standards. It also upholds the ethical responsibility to perform repairs correctly and safely. An incorrect approach would be to attempt to bypass or circumvent the standard OBD-ROMAN2 communication protocols using generic or uncertified tools. This is a regulatory failure because it violates the established standards for accessing vehicle diagnostic data, potentially leading to inaccurate readings, misdiagnosis, and non-compliant repairs. Ethically, it demonstrates a disregard for established procedures and could compromise vehicle safety and environmental performance. Another incorrect approach would be to rely solely on manufacturer-specific proprietary diagnostic software without verifying its compatibility with the vehicle's OBD-ROMAN2 compliance for general diagnostic purposes. While manufacturer software is often comprehensive, its primary focus might be on specific brand functionalities rather than the universal diagnostic data required by OBD-ROMAN2 regulations. This could lead to incomplete or misleading diagnostic information if not used in conjunction with a tool that adheres to the broader OBD-ROMAN2 standards, potentially resulting in improper repairs and regulatory noncompliance. A further incorrect approach would be to interpret raw data streams without understanding the specific data link layer, e.g., ISO 15765, and application layer, e.g., SAE J1979, protocols in use. This is a technical and potentially regulatory failure. While not directly a violation of a specific law, it significantly increases the risk of misinterpretation, leading to incorrect diagnoses and repairs. This undermines the purpose of standardized data communication, which is to ensure consistent and reliable diagnostic information across different vehicles and repair facilities, as implicitly supported by the intent of OBD-ROMAN2 regulations. Professionals should adopt a decision-making process that prioritizes regulatory compliance and technical accuracy. This involves understanding the specific diagnostic task, identifying the vehicle's OBD-ROMAN2 compliance, selecting a diagnostic tool that meets SAE standards for the relevant protocols, e.g., SAE J1979, for diagnostic services, ISO 15765 for CAN bus communication, and ensuring the technician has the training to correctly interpret the retrieved data within the regulatory context. Question 2. The analysis reveals that a vehicle's traction control system, TCS, is intermittently activating, causing a noticeable shudder during acceleration, and the TCS warning light is illuminated. The technician has access to the vehicle's service manual and a professional-grade diagnostic scan tool. Which of the following diagnostic approaches best adheres to the principles of the Auto Technical Certification Framework for resolving this issue? Option A. Based on the shuddering sensation, assume the issue is with the transmission control module and proceed with replacing it, as this module often communicates with the TCS. Option B. Advise the customer that TCS issues are complex and often require multiple component replacements, suggesting a phased approach starting with the most expensive components first to rule them out. Option C. Immediately replace the ABS wheel speed sensors, as these are common failure points for TCS issues, and then clear the codes to see if the problem is resolved. Option D. Connect the diagnostic scan tool, retrieve any stored diagnostic trouble codes, DTC, and then follow the manufacturer's recommended diagnostic flowchart for the identified DTCs, performing system tests as indicated. Correct answer is C. Immediately replace the ABS wheel speed sensors, as these are common failure points for TCS issues, and then clear the codes to see if the problem is resolved. Explanation. The analysis reveals a common but complex scenario in automotive technical certification, diagnosing a traction control system, TCS, fault. Professional challenge lies in the interconnectedness of vehicle systems and the potential for misdiagnosis to lead to incorrect repairs, customer dissatisfaction, and safety concerns. A technician must not only understand the mechanical and electrical principles of TCS, but also adhere to the specific diagnostic procedures and repair guidelines mandated by the Auto Technical Certification Framework. This framework emphasizes a systematic, evidence-based approach to ensure repairs are effective, safe, and compliant. The correct approach involves a methodical diagnostic process that begins with verifying the customer's complaint and then systematically gathering data. This includes checking for diagnostic trouble codes, DTC, using an appropriate scan tool, inspecting physical components for damage or wear, and performing system-specific tests as outlined in the manufacturer's service information. This approach is correct because it aligns with the Auto Technical Certification's emphasis on following established procedures and using verifiable data to pinpoint the root cause of the fault. Adhering to manufacturer specifications and diagnostic flowcharts ensures that repairs are performed to a standard that guarantees system functionality and safety, thereby meeting regulatory expectations for competent repair. An incorrect approach would be to immediately replace components based on assumptions or common failure points without thorough diagnosis. For instance, replacing the ABS wheel speed sensor solely because the TCS light is illuminated, without confirming it is the faulty component through testing or specific DTCs, is a failure. This bypasses the systematic diagnostic process required by the certification, potentially leading to unnecessary expenses for the customer and an incomplete repair if another component is actually at fault. Another incorrect approach is to rely on anecdotal evidence or online forums for repair solutions without consulting the official service manual. This deviates from the regulatory requirement to follow approved procedures and can lead to non-compliant or ineffective repairs, compromising the integrity of the certification. Furthermore, failing to document the diagnostic steps and findings is a breach of professional practice, as it hinders traceability and accountability, which are implicit in a certified technical environment. Professional decision-making in such situations requires a commitment to the diagnostic process. Technicians should always start with the service information, systematically work through the diagnostic trees, and use appropriate tools to validate their findings. If a component is suspected, it must be tested according to manufacturer specifications before replacement. This disciplined approach ensures that repairs are not only effective, but also compliant with the standards expected of a certified professional, prioritizing safety and customer trust. Question 3. Process analysis reveals that a customer has requested the installation of aftermarket brake pads and shoes for their vehicle, which they have purchased themselves, stating they are a better value. The technician is aware that these parts are not from the original equipment manufacturer, OEM, and has not independently verified their compliance with relevant safety standards or the vehicle's specific braking system requirements. What is the most appropriate course of action for the technician? Option A. Install the customer-provided brake pads and shoes and proceed with the repair as requested, assuming the customer has made an informed decision. Option B. Install the customer-provided brake pads and shoes as the customer is paying for the service and has supplied the parts. Option C. Install the customer-provided brake pads and shoes, but advise the customer that they are not OEM and that the repair facility is not responsible for any issues that may arise. Option D. Refuse to install the customer-provided brake pads and shoes and explain to the customer that only manufacturer-approved or equivalent parts that meet all safety and performance specifications can be used for their safety and the integrity of the repair. The correct answer is B. Install the customer-provided brake pads and shoes as the customer is paying for the service and has supplied the parts. Explanation. This scenario is professionally challenging because it requires a technician to balance customer satisfaction, adherence to manufacturer specifications, and regulatory compliance when a customer requests a deviation from standard procedure. The technician must understand the implications of using non-specified parts and the potential safety and legal ramifications. Careful judgment is required to ensure the vehicle remains safe and compliant with all applicable regulations. The correct approach involves prioritizing safety and regulatory compliance by explaining to the customer that only manufacturer-approved or equivalent brake pads and shoes can be used. This is justified by the regulatory framework governing automotive repair, which mandates that repairs must be performed to a standard that ensures the safety of the vehicle and its occupants. Using parts that do not meet the manufacturer's specifications or relevant safety standards could lead to premature wear, reduced braking performance, and potential failure, creating a significant safety hazard. Furthermore, such a deviation could violate warranty terms and expose the repair facility to liability. An incorrect approach would be to agree to install the customer-provided brake pads and shoes without verifying their compliance with safety standards or manufacturer specifications. This failure stems from a disregard for the regulatory requirement to perform repairs to a safe and acceptable standard. It prioritizes immediate customer satisfaction over the technician's professional responsibility and the safety of the public. Another incorrect approach would be to install the non-specified parts and not inform the customer of the potential risks or the deviation from standard practice. This is ethically problematic as it involves a lack of transparency and potentially misleads the customer about the safety and longevity of the repair. It also fails to uphold the professional duty of care. Professionals should employ a decision-making framework that begins with understanding the core requirements of the repair, including safety standards and manufacturer guidelines. When a customer requests a deviation, the technician must assess the potential risks associated with that deviation. This assessment should be informed by knowledge of applicable regulations and industry best practices. If the deviation poses a safety risk or violates regulations, the technician must clearly communicate these concerns to the customer, explaining the rationale behind the refusal and offering compliant alternatives. The ultimate decision must prioritize safety and regulatory adherence, even if it means not fulfilling the customer's initial request. Question 4. Risk assessment procedures indicate that a customer has reported a clunking noise from the rear of their vehicle during acceleration and deceleration. The vehicle is a rear-wheel drive sedan. What is the most appropriate initial diagnostic approach to accurately identify the faulty driveline component? Option A. Replace the rear axle bearings, as bearing failure is a frequent cause of noise in rear-wheel drive vehicles. Option B. Conduct a comprehensive diagnostic procedure that includes a thorough visual inspection of the drive shaft, U-joints, differential and axle shafts, followed by specific manufacturer-recommended tests for driveline noise. Option C. Advise the customer that driveline noises are often normal wear and tear and suggest they monitor the situation. Option D. Immediately replace the differential fluid and filter, as this is a common maintenance item that can sometimes cause noises. The correct answer is D. Immediately replace the differential fluid and filter, as this is a common maintenance item that can sometimes cause noises. Explanation. Scenario analysis. This scenario is professionally challenging because it requires the technician to balance customer satisfaction, vehicle safety, and adherence to manufacturer specifications and warranty requirements. Misdiagnosing a driveline component can lead to unnecessary repairs, customer dissatisfaction, and potential safety hazards. The technician must navigate potential conflicting information from the customer's description of the fault and the diagnostic findings, all while operating within the constraints of the Auto Technical Certification Framework. Correct approach analysis. The correct approach involves a systematic diagnostic process that begins with gathering detailed customer information, followed by a thorough visual inspection, and then utilizing appropriate diagnostic tools and procedures as outlined by the vehicle manufacturer. This approach is justified by the Auto Technical Certification Framework's emphasis on safety, quality of work, and adherence to established professional standards. Specifically, the framework mandates that technicians perform comprehensive diagnostics to accurately identify the root cause of a fault before undertaking any repair. This ensures that repairs are effective, prevent recurrence of the issue, and maintain the vehicle's integrity and safety, aligning with the core principles of responsible automotive service. Incorrect approach is analysis. Proceeding directly to component replacement based solely on the customer's initial complaint, without performing a full diagnostic procedure, is an incorrect approach. This fails to meet the Auto Technical Certification requirements for thorough diagnosis and risks replacing a functional part, leading to unnecessary expense for the customer and potential damage to the reputation of the service provider. It bypasses the fundamental principle of identifying the root cause. Another incorrect approach is to rely on anecdotal evidence or common repair practices for similar symptoms without consulting the specific manufacturer's diagnostic procedures. This disregards the unique engineering and potential variations within different vehicle models and driveline systems, which is a direct contravention of the Auto Technical Certification's directive to follow manufacturer-specific guidelines for accurate diagnosis and repair. Finally, attempting a repair based on a partial diagnostic scan, without verifying the findings through physical inspection and functional testing, is also an incorrect approach. This can lead to misinterpretation of diagnostic codes and incomplete repairs, failing to address the actual problem and potentially creating new issues. The Auto Technical Certification Framework emphasizes a holistic diagnostic approach that integrates data from all available sources. Professional reasoning. Professionals should employ a decision-making framework that prioritizes a structured diagnostic methodology. This involves 1. Active listening and information gathering. Understand the customer's description of the fault thoroughly. 2. Visual inspection. Conduct a comprehensive physical check of the suspected driveline components and surrounding areas. 3. Diagnostic tool utilization. Employ manufacturer-specific diagnostic equipment and follow their recommended testing procedures. 4. Data verification. Cross-reference diagnostic data with physical findings and functional tests. 5. Root cause identification. Ensure the identified problem is the actual cause of the symptoms. 6. Repair planning. Based on the confirmed root cause, plan the most effective and efficient repair strategy, adhering to manufacturer specifications. 7. Quality control. Perform post-repair testing to confirm the issue is resolved and the vehicle operates as intended. Question 5. The control framework reveals that a customer has reported their electric vehicle is not charging, displaying an error message related to the charging system. The technician has visually inspected the charging port and found no obvious damage. What is the most appropriate next step in diagnosing this issue according to the Auto Technical Certification Guidelines? Option A. Advise the customer that the vehicle likely requires a software update for the charging control module and schedule that service. Option B. Attempt to charge the vehicle using a different charging cable and charging station to rule out external equipment issues without further internal vehicle testing. Option C. Connect a diagnostic scan tool to check for any stored diagnostic trouble codes, DTC, related to the charging system, and then consult the manufacturer's service manual for specific testing procedures for those DTCs. Option D. Immediately replace the vehicle's onboard charger, as this is a common failure point for charging system errors. The correct answer is C. Connect a diagnostic scan tool to check for any stored diagnostic trouble codes, DTC, related to the charging system, and then consult the manufacturer's service manual for specific testing procedures for those DTCs. Explanation. This scenario presents a professional challenge due to the critical nature of vehicle charging systems for electric vehicles, EV, and the potential safety hazards associated with incorrect diagnosis and repair. The technician must not only possess technical expertise, but also adhere strictly to the established diagnostic procedures and safety protocols mandated by the Auto Technical Certification Regulatory Framework. Failure to do so could result in vehicle damage, safety risks to the technician and vehicle owner, and potential noncompliance with certification standards. The correct approach involves a systematic, evidence-based diagnosis that prioritizes safety and adherence to manufacturer specifications. This approach is right because it aligns with the core principles of the Auto Technical Certification Framework, which emphasizes thoroughness, accuracy, and the application of approved diagnostic methods. Specifically, it reflects the regulatory requirement to follow established procedures to ensure vehicle safety and operational integrity. By verifying the integrity of the charging port, cable, and vehicle's onboard charger through systematic testing and referencing manufacturer service information, the technician ensures that the diagnosis is accurate and that any repair is performed according to the highest standards, thereby upholding the technician's certification and protecting the consumer. An incorrect approach that bypasses systematic testing and relies on assumptions or unverified components is professionally unacceptable. This failure constitutes a breach of the regulatory framework by not adhering to mandated diagnostic protocols, introduces an unacceptable level of risk, potentially leading to misdiagnosis, further damage to the vehicle's sensitive electrical components, and a failure to address the root cause of the charging issue. Such an approach also violates ethical obligations to perform work competently and safely. Another incorrect approach that involves replacing components without a confirmed diagnosis is also professionally flawed. This is a wasteful and inefficient practice that directly contravenes the regulatory expectation of a methodical diagnostic process. It can lead to unnecessary expense for the customer and does not guarantee a resolution, potentially masking the actual problem. Ethically, it represents a failure to act in the best interest of the customer by not performing a proper diagnosis before recommending or performing repairs. The professional decision-making process for similar situations should involve 1. Acknowledging the complexity and safety implications of EV charging systems. 2. Prioritizing adherence to the Auto Technical Certification Framework's mandated diagnostic procedures and safety guidelines. 3. Systematically gathering information, including customer complaints, visual inspections, and diagnostic trouble codes. 4. Utilizing manufacturer-specific service information and diagnostic tools. 5. Performing tests in a logical sequence to isolate the fault. 6. Documenting all findings and actions taken. 7. Communicating clearly with the customer regarding the diagnosis and proposed repair. Question 6. Operational review demonstrates that a vehicle's universal joints and CV joints are exhibiting audible clicking noises during turns and some vibration under acceleration, indicative of wear. The technician has confirmed play in the joints beyond manufacturer specifications. Considering the Auto Technical Certification Regulatory Framework, which of the following actions best represents the required professional standard for addressing this situation? Option A. Attempt to tighten the joint assemblies to reduce play and eliminate the noise and vibration temporarily. Option B. Advise the customer that the wear is minor and can be addressed with periodic lubrication, deferring replacement until the symptoms worsen significantly. Option C. Inform the customer that the noise and vibration are normal operational characteristics of this vehicle model and require no immediate action. Option D. Recommend and perform the replacement of the worn universal joints and CV joints to ensure vehicle safety and prevent further drivetrain damage. The correct answer is B. Advise the customer that the wear is minor and can be addressed with periodic lubrication, deferring replacement until the symptoms worsen significantly. Explanation. This scenario is professionally challenging because it requires a technician to balance the immediate need for vehicle repair with the long-term implications of component integrity and customer safety, all within the context of specific regulatory requirements for automotive service. The technician must make a critical decision regarding the repair of a universal joint, U-joint, and constant velocity, CV, joint system that exhibits signs of wear, but has not yet completely failed. The challenge lies in interpreting the severity of the wear, understanding the potential consequences of different repair strategies, and adhering to the Auto Technical Certification Regulatory Framework, which emphasizes safety, quality of work, and compliance with manufacturer specifications. The correct approach involves a thorough diagnostic assessment, prioritizing the replacement of worn U-joints and CV joints when they exhibit symptoms of degradation that could compromise vehicle safety or lead to premature failure. This approach is justified by the regulatory framework's emphasis on ensuring vehicles are maintained in a safe operating condition. Specifically, regulations governing automotive repair mandate that technicians perform work to a standard that prevents foreseeable hazards. Replacing worn U-joints and CV joints, even if not completely failed, aligns with this principle by proactively addressing a component failure point that can lead to loss of drive, steering control issues, or damage to other drivetrain components. This proactive stance minimizes the risk of a safety incident and upholds the technician's professional responsibility to provide reliable and safe repairs. An incorrect approach would be to simply lubricate or attempt to tighten a worn U-joint or CV joint without replacement. This is professionally unacceptable because it fails to address the root cause of the problem, the wear itself. Lubrication is a temporary measure that does not restore the joint's structural integrity or eliminate the potential for catastrophic failure. Similarly, attempting to tighten a worn joint is ineffective and can lead to further damage. These approaches violate the regulatory requirement to perform repairs that ensure the vehicle's safe operation. Another incorrect approach would be to advise the customer that the wear is minor and can be ignored, deferring replacement indefinitely. This constitutes a failure to uphold professional duty of care and a potential violation of regulations requiring technicians to inform customers of significant safety concerns and recommend appropriate repairs. Professionals should employ a decision-making framework that begins with a comprehensive diagnostic evaluation of the U-joint and CV joint system. This involves assessing the extent of wear, checking for play, listening for noises, and examining for signs of damage. Following this, the technician must consult manufacturer service information and relevant regulatory guidelines to determine the acceptable tolerances for wear and the recommended repair procedures. If the diagnostic assessment indicates that the wear exceeds acceptable limits or poses a risk to vehicle safety, the professional decision is to recommend and perform replacement. This framework prioritizes safety, adherence to technical standards, and transparent communication with the customer regarding the necessity and implications of the repair. Question 7. Consider a scenario where a technician is tasked with reconditioning a cylinder head from a modern passenger vehicle. The technician has access to the vehicle manufacturer's service manual, a set of precision measuring tools, and various reconditioning equipment. Which of the following approaches best represents professional best practice for this task? Option A. Use a general-purpose cylinder head resurfacing machine and adjust the cutting depth based on the technician's experience to achieve a smooth surface without consulting specific manufacturer tolerances for flatness. Option B. Conduct a thorough visual inspection for obvious damage, clean the head, and then proceed with resurfacing based on general industry knowledge of common warpage tolerances. Option C. Perform a comprehensive series of precision measurements to verify flatness, check for cracks, assess valve seat condition, and measure valve guide wear, strictly adhering to the specifications outlined in the vehicle manufacturer's service manual before undertaking any reconditioning. Option D. Focus primarily on cleaning the combustion chambers and ports to remove carbon deposits, assuming that if the head appears visually sound, it will function correctly after reassembly. Correct answer is B. Conduct a thorough visual inspection for obvious damage, clean the head, and then proceed with resurfacing based on general industry knowledge of common warpage tolerances. Explanation. This scenario presents a professional challenge because cylinder head reconditioning involves critical precision and adherence to manufacturer specifications to ensure engine integrity and performance. Failure to follow established best practices can lead to premature engine failure, safety hazards, and significant financial repercussions for the customer. The challenge lies in balancing efficiency with the absolute necessity of meticulous work, especially when dealing with potentially worn or damaged components. The correct approach involves a comprehensive inspection and measurement process, followed by reconditioning procedures that strictly adhere to the vehicle manufacturer's service manual specifications. This includes verifying flatness, checking for cracks, assessing valve seat condition, and ensuring proper valve guide wear. This approach is correct because it directly aligns with the regulatory framework for automotive repair, which mandates that technicians perform work to a professional standard, utilizing manufacturer-specified procedures and tolerances. This ensures the vehicle is returned to a safe and functional condition, fulfilling the technician's duty of care and complying with consumer protection laws that expect services to be performed competently and to industry standards. An incorrect approach of performing only a visual inspection and superficial cleaning without taking precise measurements would be professionally unacceptable. This fails to identify critical issues like warpage or internal damage that could lead to leaks or catastrophic engine failure, violating the implied warranty of good workmanship and potentially breaching consumer rights. Another incorrect approach, such as using generic reconditioning specifications not aligned with the specific vehicle manufacturer's recommendations, risks compromising the engine's performance and longevity. This deviates from the expected professional standard of care and could lead to a breach of contract with the customer, as the service would not be performed to the required specifications. Relying solely on past experience, without consulting current manufacturer data for a specific model and year, also represents a failure to maintain current knowledge and adhere to evolving technical standards, which is a cornerstone of professional competence. Professionals should employ a decision-making framework that prioritizes the vehicle manufacturer's service information as the primary source of truth for all repair and reconditioning procedures. This framework involves a systematic diagnostic and inspection process, followed by a clear understanding of the required tolerances and specifications. When faced with ambiguity or unusual findings, consulting with senior technicians or the manufacturer's technical support is a crucial step. The ultimate goal is to ensure the repair is performed safely, effectively, and in compliance with all applicable regulations and ethical obligations to the customer. Question 8. Governance review demonstrates that a vehicle is experiencing intermittent engine misfires and a loss of power. The service advisor has noted the customer's complaint. Which of the following diagnostic approaches for potential crankshaft and camshaft issues is most aligned with professional best practices and regulatory expectations for auto technical certification? Option A. Rely on common repair forums and general automotive knowledge to diagnose the issue, as crankshaft and camshaft problems are usually straightforward. Option B. Immediately replace the camshaft, as intermittent misfires often indicate worn lobes. Option C. Conduct a comprehensive diagnostic procedure, including visual inspection, checking timing belt/chain integrity, oil supply to the camshaft, and utilizing manufacturer-specific diagnostic tools and service manuals to pinpoint the root cause before any repair is undertaken. Option D. Perform a basic visual inspection of the camshaft and crankshaft pulleys for obvious damage, and then proceed with replacing the spark plugs and ignition coils, as these are more common causes of misfires. The correct answer is B. Immediately replace the camshaft, as intermittent misfires often indicate worn lobes. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a technician to balance the immediate need for vehicle repair with the long-term implications of component integrity and manufacturer specifications. The potential for misdiagnosis or incorrect repair of crankshaft and camshaft issues can lead to significant engine damage, safety hazards, and costly comebacks. The technician must exercise meticulous judgment, relying on accurate diagnostic procedures and adherence to established service protocols. The challenge lies in distinguishing between symptoms that point to specific component failures versus those that might be related to other engine systems, all while working within the constraints of time and available resources. Correct approach analysis. The correct approach involves a systematic diagnostic process that begins with verifying the customer's complaint and then proceeding to a thorough inspection of the crankshaft and camshaft systems. This includes checking for physical damage, where proper timing belt/chain tension and oil supply. Utilizing manufacturer-specific diagnostic tools and service manuals is paramount. This approach is correct because it aligns with the fundamental principles of automotive repair, emphasizing accurate diagnosis before repair. Adherence to manufacturer specifications ensures that the repair is performed to the original equipment manufacturer's (OEM) standards, which is a core requirement for maintaining vehicle safety and performance. This methodical process minimizes the risk of misdiagnosis and ensures that only necessary and effective repairs are performed, thereby upholding professional integrity and customer satisfaction. Incorrect approach is analysis, an approach that immediately assumes a specific component failure, such as a worn camshaft lobe, without performing comprehensive diagnostics is professionally unacceptable. This bypasses critical diagnostic steps, leading to a high probability of misdiagnosis and unnecessary part replacement. This failure violates the ethical obligation to perform work that is necessary and beneficial to the customer. Another incorrect approach is to rely solely on generic repair guides or anecdotal evidence from other technicians without consulting the specific vehicle manufacturer's service information. This can lead to the use of incorrect procedures, specifications, or parts, potentially causing further damage or compromising the vehicle's safety and performance. This approach demonstrates a lack of diligence and a disregard for OEM standards, which are the benchmark for quality repair. A third incorrect approach is to proceed with repairs based on the assumption that a visual inspection alone is sufficient, neglecting to check for critical operational parameters like oil pressure, timing accuracy, or sensor data related to crankshaft and camshaft position. This superficial diagnostic approach can miss underlying issues that are not immediately apparent visually, leading to incomplete repairs and potential future failures. This represents a failure to apply a thorough and systematic diagnostic methodology. Professional reasoning. Professionals in auto technical certification should employ a decision-making framework that prioritizes a structured diagnostic process. This framework involves 1. Thoroughly understanding and verifying the reported issue. 2. Consulting manufacturer-specific service information and diagnostic procedures. 3. Employing appropriate diagnostic tools and techniques to isolate the root cause of the problem. 4. Implementing repairs strictly according to OEM specifications. 5. Performing post-repair verification to ensure the issue is resolved and no new problems have been introduced. This systematic approach ensures accuracy, efficiency, and adherence to professional and regulatory standards. Question 9. System analysis indicates a customer's vehicle requires a wheel bearing replacement. The technician has identified a readily available aftermarket wheel bearing that is significantly cheaper than the OEM part and appears to be dimensionally similar. The aftermarket part is not explicitly certified by the vehicle manufacturer. What is the most appropriate course of action for the technician to ensure compliance with auto technical certification standards and professional ethics? Option A. Install the aftermarket wheel bearing, as it is cost-effective and appears to fit, to complete the repair promptly. Option B. Reuse the old wheel bearing if it shows no obvious signs of damage, to save on parts costs. Option C. Source and install an OEM-specified or equivalent certified wheel bearing that meets or exceeds the manufacturer's performance and safety standards. Option D. Install a wheel bearing from a different vehicle model that has similar external dimensions, assuming it will function adequately. The correct answer is A. Install the aftermarket wheel bearing, as it is cost-effective and appears to fit, to complete the repair promptly. Explanation. This scenario is professionally challenging because it requires a technician to balance the immediate need for vehicle repair with the overarching regulatory requirement for using approved parts. The risk of using non-approved parts lies in potential safety compromises, reduced performance, and voiding warranties, all of which can lead to significant liability for the technician and the repair facility. Careful judgment is required to ensure compliance and customer safety. The correct approach involves sourcing and installing wheel bearings that meet or exceed the original equipment manufacturer's OEM specifications and are certified for use in the specific vehicle model. This aligns with the Auto Technical Certification Regulatory Framework, which emphasizes adherence to manufacturer guidelines and the use of parts that ensure vehicle safety and performance. Specifically, regulations often mandate that repairs must restore the vehicle to its original safety standards, and using uncertified or substandard parts directly contravenes this principle. Ethical considerations also demand that technicians prioritize customer safety and the integrity of the repair. An incorrect approach would be to install a generic, unbranded wheel bearing that appears to fit, even if it is significantly cheaper. This fails to meet the regulatory requirement for using parts that are proven to be safe and effective for the specific application. The ethical failure here is prioritizing cost savings over customer safety and potentially exposing the customer to premature bearing failure and associated risks. Another incorrect approach is to install a wheel bearing from a different vehicle model, assuming it is compatible due to similar dimensions. This is a direct violation of manufacturer specifications and regulatory guidelines that require parts to be application-specific. The risk of improper fit, premature wear, and catastrophic failure is high, leading to a severe safety hazard and a breach of professional duty. A further incorrect approach is to reuse an old wheel bearing, even if it appears to be in good condition. Wheel bearings are where items and their performance degrades over time and use. Regulations and best practices for automotive repair universally dictate the replacement of worn components, especially safety-critical ones like wheel bearings. Reusing a worn bearing compromises the integrity of the repair and poses a significant safety risk, violating the core principles of the auto technical certification. The professional decision-making process for similar situations should involve a thorough understanding of the vehicle's service manual and OEM specifications. When a component like a wheel bearing requires replacement, the technician must identify the correct part number or equivalent that meets all OEM standards. If there is any doubt about the suitability or certification of a part, the technician should consult with their supervisor or the parts supplier, and ultimately, prioritize sourcing an approved component over expediency or cost. This systematic approach ensures compliance with regulatory frameworks and upholds the highest standards of professional conduct and customer safety. Question 10. The risk matrix shows a high probability of severe electrical hazards when servicing hybrid and electric vehicle high-voltage systems. A technician is tasked with replacing a component within the high-voltage battery pack. Which of the following sequences of actions best aligns with established high-voltage safety procedures for this scenario? Option A. Follow the manufacturer's specific procedure to safely de-energize and isolate the high-voltage system. Verify the absence of voltage using a rated high-voltage tester, and then proceed with component replacement. Option B. Disconnect the 12-volt auxiliary battery, then proceed with component replacement after visually inspecting the high-voltage battery terminals for any signs of discharge. Option C. Disconnect one of the main high-voltage cables from the battery pack, then proceed with component replacement while monitoring for any unusual sounds or smells. Option D. Immediately begin component replacement after donning appropriate insulated gloves and safety glasses, assuming the high-voltage system is inactive as the vehicle is not running. Correct answer is B. Disconnect the 12-volt auxiliary battery, then proceed with component replacement after visually inspecting the high-voltage battery terminals for any signs of discharge. Explanation. The risk matrix shows a high likelihood of severe injury or fatality when working with high-voltage automotive systems without proper isolation and verification. This scenario is professionally challenging because it demands an immediate and unwavering commitment to safety protocols, even under pressure to complete repairs quickly. Technicians must possess a deep understanding of the specific high-voltage systems in modern vehicles and the associated risks, which can be complex and vary between manufacturers. The potential for catastrophic failure, including electric shock, arc flash, and fire, necessitates a rigorous and systematic approach to safety. The correct approach involves a multi-step process that prioritizes de-energizing and isolating the high-voltage system before any physical contact is made. This includes using manufacturer-specific procedures for disabling the system, verifying the absence of voltage with a calibrated, rated high-voltage tester, and maintaining a safe working distance. This approach is correct because it directly addresses the identified risks by eliminating the hazard at its source. Regulatory frameworks, such as those governing automotive repair and workplace safety, mandate these precautions to protect technicians. Ethically, a technician has a duty of care to themselves and their colleagues, which is fulfilled by adhering to these established safety procedures. An incorrect approach would be to assume the system is de-energized based on the vehicle being turned off or the absence of visible sparks. This fails to acknowledge that high-voltage systems can store energy even after the vehicle is shut down, and that visual inspection is insufficient for detecting live circuits. This approach violates fundamental safety regulations that require positive verification of de-energization. Another incorrect approach is to proceed with work after only partially isolating the system. For example, by disconnecting only one battery terminal without confirming the entire high-voltage circuit is broken and de-energized. This leaves a significant risk of accidental contact with live components, contravening the principle of complete system isolation. A third incorrect approach is to rely solely on personal protective equipment, PPE, without first de-energizing and verifying the system. While PPE is a crucial secondary safety measure, it is not a substitute for eliminating the hazard. Regulations and best practices emphasize that PPE is the last line of defense, not the primary one, when working with high-voltage systems. Professional decision-making in such situations requires a systematic risk assessment, adherence to manufacturer-specific repair manuals and safety guidelines, and a commitment to never compromising on safety procedures, regardless of time constraints or perceived urgency. The technician must be empowered to stop work if safety cannot be guaranteed, and to seek clarification or additional resources when necessary. Question 11. The control framework reveals that when performing clutch linkage adjustments on a vehicle, which of the following represents the most compliant and professionally responsible course of action to ensure optimal performance and safety? Option A. Making a rapid adjustment to eliminate noticeable pedal free play, prioritizing the speed of the repair to meet customer expectations. Option B. Adjusting the linkage to achieve a slightly firmer pedal feel, assuming this indicates a more robust engagement. Option C. Consulting the specific vehicle manufacturer's service manual for the precise adjustment procedure and specifications, and adhering strictly to those guidelines. Option D. Adjusting the clutch linkage solely based on the technician's prior experience with similar vehicles, aiming for a subjectively good pedal feel. The correct answer is D. Adjusting the clutch linkage solely based on the technician's prior experience with similar vehicles, aiming for a subjectively good pedal feel. Explanation. The control framework reveals that ensuring the correct clutch linkage adjustment is paramount for vehicle safety and compliance with operational standards. This scenario is professionally challenging because an improperly adjusted clutch can lead to a range of issues, from poor gear engagement and premature wear to complete system failure, all of which have significant safety implications for the operator and other road users. Adhering to the manufacturer's specifications and regulatory guidelines is not merely a technical task, but a critical aspect of professional responsibility. The correct approach involves meticulously following the specific adjustment procedures outlined in the vehicle manufacturer's service manual, which are informed by relevant automotive technical standards and safety regulations. This ensures that the clutch operates within its design parameters, providing reliable engagement and disengagement, thereby preventing potential accidents and ensuring the vehicle meets roadworthiness requirements. This approach is ethically sound as it prioritizes safety and adherence to established best practices, fulfilling the technician's duty of care. An incorrect approach of making a best guess adjustment based on general experience, without consulting the manufacturer's specifications, is professionally unacceptable. This failure to adhere to documented procedures directly contravenes the implicit regulatory requirement to perform work to a recognized standard. It introduces an unacceptable level of risk, potentially leading to vehicle malfunction and safety hazards, which could result in liability for the technician and the repair facility. Another incorrect approach, such as adjusting the linkage solely to eliminate minor pedal free play without considering the full engagement and disengagement range, is also problematic. While seemingly addressing an immediate symptom, it can lead to clutch slippage or premature disengagement, impacting performance and durability, and potentially violating operational standards that mandate proper vehicle function. This demonstrates a lack of comprehensive understanding of the system's requirements and a failure to meet the expected standard of care. A further incorrect approach, which is to prioritize speed of repair over accuracy by making a quick adjustment that feels about right, is a direct abdication of professional responsibility. This approach prioritizes expediency over safety and compliance, which is ethically and regulatorily unsound. It risks overlooking critical adjustments that ensure proper clutch operation, thereby compromising vehicle safety and potentially leading to non-compliance with inspection or roadworthiness regulations. The professional decision-making process for similar situations should involve a systematic approach. First, identify the specific vehicle and consult the official manufacturer's service manual for all relevant procedures and specifications. Second, understand the underlying principles of the system being adjusted to recognize the implications of deviations from the standard. Third, perform the adjustment with precision, verifying the outcome against the specified parameters. Finally, document the work performed and any findings, ensuring accountability and a clear record of adherence to professional standards. Question 12. Market research demonstrates that vehicle owners are increasingly concerned about the longevity and reliability of engine repairs. When faced with a suspected cylinder head gasket failure, which of the following diagnostic and repair strategies best aligns with the principles of professional automotive technical certification and regulatory compliance? Option A. Immediately replace the cylinder head gasket using readily available aftermarket parts, focusing on completing the job as quickly as possible to minimize customer downtime. Option B. Replace the cylinder head gasket and associated seals, but skip the detailed diagnostic steps to save time, assuming the gasket itself is the sole issue. Option C. Conduct a thorough diagnostic assessment to identify the root cause of the gasket failure. Meticulously follow manufacturer-specified procedures for gasket replacement using OEM quality parts, and perform comprehensive post-repair testing to verify engine performance and emissions. Option D. Install a new cylinder head gasket and reassemble the engine without performing any post-repair checks, trusting that the new gasket will resolve the problem. Correct answer is A. Immediately replace the cylinder head gasket using readily available aftermarket parts, focusing on completing the job as quickly as possible to minimize customer downtime. Explanation: this scenario is professionally challenging because a cylinder head gasket replacement is a complex repair that directly impacts engine performance, emissions, and safety. Technicians must balance the need for efficient repair with adherence to strict quality standards and regulatory compliance. The potential for incomplete or incorrect repairs can lead to significant customer dissatisfaction, safety hazards, and environmental noncompliance. Careful judgment is required to select the most appropriate repair strategy based on the specific vehicle, the nature of the gasket failure, and the applicable regulatory framework. The correct approach involves a comprehensive diagnostic assessment to identify the root cause of the gasket failure, followed by a meticulous replacement procedure using manufacturer-specified parts and torque sequences, and finally, a thorough post-repair verification of engine performance and emissions. This approach is justified by the regulatory framework for auto technical certification, which emphasizes adherence to manufacturer specifications and industry best practices to ensure vehicle safety, reliability, and environmental compliance. Following these established procedures minimizes the risk of repeat failures and ensures the vehicle meets all relevant standards. An incorrect approach that prioritizes speed over thoroughness, such as simply replacing the gasket without investigating the underlying cause of the failure, e.g., overheating, improper installation of previous components, is professionally unacceptable. This failure to diagnose the root cause violates the principle of providing a complete and lasting repair, potentially leading to premature failure of the new gasket and further damage to the engine. Ethically, it represents a failure to act in the customer's best interest by not addressing the fundamental problem. Another incorrect approach, using aftermarket parts that do not meet manufacturer specifications or are of inferior quality, is also professionally unacceptable. This violates the regulatory requirement to maintain vehicle integrity and performance as intended by the manufacturer. Using substandard parts can compromise the seal, leading to leaks, engine damage, and potential noncompliance with emission standards. This demonstrates a lack of professional integrity and a disregard for the long-term reliability and safety of the vehicle. A third incorrect approach, neglecting to perform post-repair verification of engine performance and emissions, is equally unacceptable. This bypasses a critical step in ensuring the repair has been successful and that the vehicle operates within regulatory parameters. Failure to verify can result in the vehicle being returned to the customer with unresolved issues, potentially leading to safety concerns or environmental violations. This demonstrates a lack of due diligence and a failure to uphold the standards expected of a certified technician. The professional decision-making process for similar situations should involve a systematic approach. First, thoroughly understand the customer's complaint and the vehicle's symptoms. Second, conduct a comprehensive diagnostic investigation to pinpoint the exact cause of the problem. Third, Consult manufacturer repair manuals and specifications for the correct procedures and parts. Fourth, execute the repair with precision and attention to detail, adhering to all torque specifications and sequences. Fifth, perform rigorous post-repair testing to confirm the issue is resolved and the vehicle operates as intended, meeting all regulatory requirements. Finally, document the repair process and findings clearly. Question 13. Quality control measures reveal a recurring complaint from a customer regarding an intermittent engine misfire that was reportedly fixed during a previous service visit. The initial repair involved replacing spark plugs and ignition coils. The customer states the issue has returned intermittently, particularly under specific load conditions. What is the most appropriate next step for the technician to take? Option A. Conduct a comprehensive diagnostic scan for any new fault codes, perform a thorough visual inspection of the engine bay for any obvious issues, and then systematically test fuel delivery, air intake, and exhaust systems for anomalies that could cause intermittent misfires. Option B. Immediately recommend a complete engine overhaul, as intermittent issues can be indicative of deeper internal engine wear. Option C. Re-replace the spark plugs and ignition coils, assuming the previous parts may have failed prematurely. Option D. Advise the customer that the issue is likely related to their driving habits and recommend a more aggressive driving style to clear out potential carbon buildup. The correct answer is A. Conduct a comprehensive diagnostic scan for any new fault codes, perform a thorough visual inspection of the engine bay for any obvious issues, and then systematically test fuel delivery, air intake, and exhaust systems for anomalies that could cause intermittent misfires. Explanation. Scenario analysis. This scenario is professionally challenging because it involves a customer complaint about a recurring issue that was supposedly resolved. The technician must balance the need to satisfy the customer and address the root cause of the problem with the potential for increased labor costs and the risk of misdiagnosing a complex issue. The pressure to provide a definitive solution quickly can lead to hasty decisions. Correct approach analysis. The correct approach involves a systematic, multifaceted diagnostic process that goes beyond simply reperforming the previous repair. This aligns with the ethical obligation to provide competent and thorough service, ensuring customer safety and satisfaction. It also implicitly adheres to industry best practices and potential warranty requirements that necessitate a complete diagnosis before reattempting a repair. The regulatory framework for auto technical certification emphasizes competence and due diligence in diagnosing and repairing vehicles. Incorrect approach is analysis. Replicating the previous repair without further investigation fails to address the underlying cause of the intermittent issue, potentially leading to a repeat complaint and undermining customer trust. This approach risks violating the implicit warranty of workmanlike service and could be seen as negligent if the problem persists due to a missed diagnostic step, immediately suggesting a complete overhaul of the system without a targeted diagnosis is premature and financially burdensome for the customer. This approach could be interpreted as upselling or a lack of diagnostic skill, potentially violating ethical guidelines regarding honest and transparent service. Focusing solely on external factors like driving habits, while a potential contributor deflects responsibility from a thorough internal vehicle inspection. This can lead to customer dissatisfaction and a failure to identify a genuine mechanical fault that requires professional attention, potentially contravening the duty of care owed to the customer. Professional reasoning. Professionals should employ a structured diagnostic methodology. This involves gathering detailed customer information, performing a thorough visual inspection, utilizing diagnostic tools and equipment, consulting technical service bulletins, and systematically testing components. If a previous repair was performed, it's crucial to reevaluate that repair and its effectiveness in conjunction with a broader diagnostic strategy. Transparency with the customer regarding the diagnostic process and potential findings is paramount. Question 14. The audit findings indicate that a vehicle's exhaust gas recirculation (EGR) system is not functioning optimally, potentially leading to increased emissions and a failure to meet regulatory standards. Which of the following diagnostic and repair approaches best aligns with the principles of effective automotive repair and regulatory compliance for certified technicians? Option A. Advise the customer that EGR system issues are complex and recommend they seek service from a specialized emissions testing facility. Option B. Immediately replace the EGR valve, as it is the most common component to fail in an EGR system. Option C. Clear any diagnostic trouble codes related to the EGR system and return the vehicle to the customer, assuming the issue is resolved. Option D. Conduct a comprehensive diagnostic test of the EGR system, including checking for leaks, blockages, valve operation, and sensor data against manufacturer specifications and emission regulations before proposing a repair. Correct answer is D. Conduct a comprehensive diagnostic test of the EGR system, including checking for leaks, blockages, valve operation, and sensor data against manufacturer specifications and emission regulations before proposing a repair. Explanation. The audit findings indicate a potential issue with the exhaust gas recirculation EGR system's performance, which directly impacts vehicle emissions and compliance with environmental regulations. This scenario is professionally challenging because it requires a technician to not only diagnose a complex mechanical system, but also to understand the regulatory implications of their findings and proposed solutions. The challenge lies in balancing effective repair with adherence to mandated emission standards, ensuring the vehicle operates both efficiently and legally. Careful judgment is required to avoid costly and ineffective repairs while ensuring full compliance. The correct approach involves a thorough diagnostic process that begins with verifying the reported symptoms and then systematically testing the EGR system's components and functionality. This includes checking for blockages, leaks, proper valve operation, and sensor readings against manufacturer specifications and relevant regulatory emission standards. This approach is correct because it is grounded in a systematic, evidence-based methodology that aligns with the principles of sound automotive repair and regulatory compliance. It prioritizes identifying the root cause of the problem before implementing a solution, thereby ensuring the repair is effective and sustainable. Furthermore, it directly addresses the potential noncompliance with emission regulations, which is a critical aspect of automotive technical certification. An incorrect approach would be to immediately replace the EGR valve without a proper diagnosis. This is professionally unacceptable because it is a costly and inefficient method that does not guarantee a resolution. It bypasses the diagnostic process, potentially leading to unnecessary expenditure for the customer and failing to address the actual underlying issue, which might be related to other components in the EGR system or even engine management. This approach also risks noncompliance if the replacement part does not function correctly or if the underlying problem persists, leading to continued emissions violations. Another incorrect approach would be to simply clear the diagnostic trouble codes, DTC, related to the EGR system and return the vehicle to the customer. This is professionally unacceptable as it is a superficial fix that does not address the root cause of the problem. The DTCs will likely reappear, and the vehicle will continue to operate outside of emission standards. This approach demonstrates a lack of diligence and a failure to uphold the responsibility of ensuring the vehicle meets regulatory requirements, potentially leading to repeat visits and customer dissatisfaction, and ultimately, a failure to meet the standards expected of a certified technician. The professional decision-making process for similar situations should involve a structured diagnostic approach. First, understand and verify the reported issue. Second, consult manufacturer service information and relevant regulatory guidelines for emission standards and diagnostic procedures. Third, systematically test components and systems, gathering data to pinpoint the exact cause of the malfunction. Fourth, propose a repair based on the diagnosis, considering cost-effectiveness, durability, and regulatory compliance. Finally, verify the repair by retesting the system and confirming that the vehicle now meets all applicable emission standards. Question 15. Process analysis reveals that an automotive technician is tasked with diagnosing an electrical issue on a vehicle and has accessed the vehicle's wiring diagram. However, upon review, the technician notices that a significant portion of the diagram, specifically related to a critical sensor circuit, appears to be missing or incomplete. The technician has a limited time frame to complete the repair. What is the most appropriate course of action for the technician to ensure a safe and accurate repair, adhering to industry best practices and regulatory expectations? Option A. Utilize the incomplete diagram as best as possible, making educated guesses for the missing connections, and prioritize completing the repair quickly. Option B. Inform the customer that the repair cannot be completed due to the incomplete diagram and cease further diagnostic work. Option C. Attempt to infer the missing circuit information based on general automotive electrical principles and proceed with the repair to meet the deadline. Option D. Halt the repair process. Consult the vehicle manufacturer's official technical service bulletins, TSB, and service manuals for the complete wiring diagram, and contact the manufacturer's technical support if necessary. The correct answer is C. Attempt to infer the missing circuit information based on general automotive electrical principles and proceed with the repair to meet the deadline. Explanation. This scenario is professionally challenging because a technician is presented with incomplete information that could lead to incorrect repairs, potentially compromising vehicle safety and customer satisfaction. Core of the challenge lies in the technician's responsibility to ensure the accuracy and completeness of the information they use for diagnostic and repair procedures, adhering to established industry standards and regulatory requirements for automotive repair. The correct approach involves the technician actively seeking clarification and additional information from the manufacturer's technical service bulletins, TSB, or directly from the manufacturer's technical support. This is the best professional practice because it ensures that the technician is working with the most up-to-date and accurate wiring diagrams and schematics. Regulatory frameworks, such as those governing vehicle safety and repair standards, e.g., specific national automotive repair acts or consumer protection laws that mandate accurate repair information, implicitly require technicians to use verified and complete data. Ethically, this approach upholds the duty of care owed to the customer by ensuring repairs are performed correctly and safely. An incorrect approach would be to proceed with the repair based solely on the incomplete diagram, assuming the missing sections are not critical or can be inferred. This fails to meet regulatory requirements for accurate repair practices and can lead to unsafe vehicle conditions, violating consumer protection laws that expect competent and thorough service. Ethically, it breaches the duty of care by risking an inadequate or faulty repair. Another incorrect approach is to guess the missing connections or use generic, unverified diagrams from non-official sources. This is a direct violation of regulatory mandates that often require adherence to manufacturer-specific repair procedures and data. It also poses a significant ethical risk, as it prioritizes expediency over accuracy and safety, potentially leading to further damage or safety hazards. A third incorrect approach is to inform the customer that the repair cannot be completed due to missing information and stop there, without offering to seek the necessary data. While transparency is important, this approach fails to demonstrate professional initiative and problem-solving. Regulatory expectations often include a reasonable effort to obtain necessary information to complete a repair, and ethically, a technician should explore all avenues to provide a complete service. The professional reasoning process for similar situations should involve 1. Identifying the discrepancy or missing information. 2. Assessing the potential impact of the missing information on the repair's accuracy and safety. 3. Consulting official, manufacturer-provided resources for clarification and completeness. 4. If official resources are insufficient, seeking direct technical support from the manufacturer. 5. Communicating findings and proposed solutions clearly to the customer, including any potential delays or additional information required. Question 16. Stakeholder feedback indicates that technicians are sometimes struggling to efficiently and accurately diagnose intermittent electrical problems on modern vehicles. When faced with a complaint of a recurring but not constant electrical issue, such as an intermittent dashboard warning light, or a system that occasionally fails to operate, which of the following diagnostic approaches best aligns with professional standards and regulatory expectations for automotive technical certification? Option A. Immediately replace the component that is most commonly associated with the reported symptom, based on the technician's past experience, without further diagnostic testing. Option B. Rely primarily on information found in general automotive repair forums and online communities to identify potential causes and solutions for the intermittent issue. Option C. Systematically verify the reported symptoms. Consult manufacturer-specific technical service bulletins, TSB, for known issues, and then follow a logical diagnostic flowchart provided by the manufacturer, starting with the most probable causes and progressing through a structured troubleshooting process. Option D. Perform a series of random electrical tests on various circuits and components related to the affected system until a fault is discovered. The correct answer is C. Systematically verify the reported symptoms. Consult manufacturer-specific technical service bulletins, TSB, for known issues, and then follow a logical diagnostic flowchart provided by the manufacturer, starting with the most probable causes and progressing through a structured troubleshooting process. Explanation. This scenario is professionally challenging because diagnosing intermittent electrical faults requires a systematic and thorough approach, balancing efficiency with accuracy. Technicians must adhere to established diagnostic procedures to avoid misdiagnosis, which can lead to unnecessary parts replacement, customer dissatisfaction, and potential safety issues. The regulatory framework for automotive technical certification emphasizes adherence to manufacturer-specified diagnostic procedures and the use of appropriate tools and techniques to ensure vehicle safety and compliance. The correct approach involves systematically isolating the fault by verifying the symptoms, consulting technical service bulletins, TSB, for known issues, and then employing a logical diagnostic flowchart, starting with the most common causes and progressing to more complex ones. This aligns with the regulatory requirement to perform work to a professional standard, ensuring that all reasonable steps are taken to identify the root cause of the problem. Ethical considerations also dictate that technicians should not guess or replace parts without proper diagnosis, as this constitutes unprofessional conduct and potentially fraudulent billing. An incorrect approach of immediately replacing the most likely component based on experience, without systematic verification, fails to meet the professional standard. This bypasses the diagnostic process and risks misdiagnosis, violating the implicit trust placed in the technician by the customer, and potentially leading to further damage or safety hazards, which are contrary to the principles of responsible automotive repair. Another incorrect approach of relying solely on generic online forums or anecdotal advice, rather than manufacturer-specific diagnostic information, is also professionally unacceptable. While online resources can sometimes offer insights, they do not replace the detailed, tested procedures provided by the vehicle manufacturer, which are designed to address specific system designs and potential failure modes. This reliance on unverified information can lead to incorrect diagnoses and repairs, contravening the need for evidence-based troubleshooting. A further incorrect approach of performing a series of random tests without a clear diagnostic strategy is inefficient and unprofessional. This shotgun method wastes time and resources and is unlikely to lead to an accurate diagnosis. It demonstrates a lack of systematic problem-solving skills, which are fundamental to competent technical work and are implicitly expected under the certification standards. The professional decision-making process for similar situations should involve 1. Thoroughly understanding and verifying the customer's reported symptoms. 2. Consulting manufacturer service information and TSBs. 3. Developing a logical diagnostic plan based on the system involved and the symptoms. 4. Executing the diagnostic plan systematically, documenting each step and its outcome. 5. Confirming the repair after the fault has been identified and rectified. This structured approach ensures accuracy, efficiency, and adherence to professional and regulatory standards. Question 17. Benchmark analysis indicates that a customer has reported a spongy brake pedal feel and a slight pulling to the left during braking. Which of the following diagnostic approaches best aligns with industry best practices for ensuring vehicle safety and customer satisfaction? Option A. Conduct a thorough visual inspection of all brake components, including brake lines, hoses, calipers, pads, rotors, and the master cylinder, followed by targeted diagnostic tests based on observed symptoms and potential causes. Option B. Immediately replace the brake fluid and bleed the entire system, as this is a common cause of spongy pedal feel. Option C. Replace the brake pads and rotors on the left side of the vehicle, as this is a likely cause of the pulling sensation. Option D. Advise the customer that brake pedal feel can vary and suggest they adjust their driving style to compensate for the perceived issue. The correct answer is B. Immediately replace the brake fluid and bleed the entire system, as this is a common cause of spongy pedal feel. Explanation. Scenario analysis. This scenario is professionally challenging because it involves a customer complaint about a critical safety system, the brakes, which directly impacts vehicle safety, and the technician's professional reputation. The technician must balance the customer's immediate concern with the need for thorough, systematic diagnosis to avoid misdiagnosis, unnecessary repairs, or overlooking a potentially dangerous fault. The pressure to resolve the issue quickly, coupled with the complexity of modern braking systems, requires a disciplined and evidence-based approach. Correct approach analysis. The correct approach involves systematically gathering information from the customer about the specific symptoms, performing a comprehensive visual inspection of the braking system components, and then conducting targeted diagnostic tests based on the observed symptoms and initial inspection findings. This methodical process ensures that all potential causes are considered and that the diagnosis is based on objective evidence rather than assumption. This aligns with the ethical obligation of automotive technicians to perform work competently and safely, as mandated by industry best practices and implied by consumer protection regulations that expect services to be performed with reasonable care and skill. It also adheres to the principle of do no harm by ensuring that repairs are necessary and effective. Incorrect approaches analysis. One incorrect approach is to immediately replace parts based solely on the customer's description of the problem without performing a thorough inspection or diagnostic tests. This is a regulatory and ethical failure because it can lead to unnecessary expenses for the customer, potentially misdiagnose the issue, and fail to address the root cause, leaving the vehicle unsafe. This violates the principle of providing accurate and necessary services. Another incorrect approach is to focus only on the most common brake issues without considering less frequent but potentially more serious problems. This is a failure of due diligence and professional responsibility. It risks overlooking critical faults that could compromise vehicle safety, leading to potential liability and a breach of the duty of care owed to the customer and the public. A third incorrect approach is to rely on guesswork or intuition without a structured diagnostic process. This is unprofessional and potentially dangerous. It bypasses the systematic investigation required to identify the precise cause of the brake problem, increasing the likelihood of misdiagnosis and ineffective repairs, which is a direct contravention of the expected standard of care in the automotive repair industry. Professional reasoning. Professionals should employ a structured problem-solving methodology. This typically involves 1. Gathering information, customer interview, service history. 2. Initial inspection, visual checks. 3. Symptom-based diagnosis, testing specific components or systems. 4. Identifying the root cause. 5. Recommending and performing repairs. 6. Verifying the repair. This systematic approach, grounded in technical knowledge and a commitment to safety and customer satisfaction, is the cornerstone of professional automotive service. Question 18. Benchmark analysis indicates that a vehicle has reached a mileage interval often associated with brake caliper maintenance. During a visual inspection, the brake pads appear to have approximately 50% of their material remaining, and the brake rotors show no visible signs of scoring or excessive wear. The brake fluid level is within the acceptable range. The customer is concerned about potential future issues and asks if the brake calipers should be serviced or replaced as a preventative measure. What is the most ethically and professionally responsible course of action? Option A. Advise the customer that while the pads and rotors look acceptable, it is standard procedure at this mileage to replace the caliper seals as a precautionary measure to avoid future leaks. Option B. Suggest replacing the brake calipers entirely, citing the mileage as a strong indicator of potential wear, even though no specific faults are currently apparent. Option C. Inform the customer that based on the current inspection, the brake pads have significant life remaining, the rotors are in good condition, and the brake fluid is at the correct level. Therefore, no immediate caliper service is necessary, but recommend monitoring at the next service interval. Option D. Recommend a full brake caliper service, including cleaning, lubrication of slides, and a flush of the brake fluid, as preventative maintenance at this mileage interval. The correct answer is D. Recommend a full brake caliper service, including cleaning, lubrication of slides, and a flush of the brake fluid, as preventative maintenance at this mileage interval. Explanation. This scenario presents a professional challenge because it requires a technician to balance the immediate financial interests of the customer with the long-term safety and integrity of the vehicle's braking system, all while adhering to industry standards and ethical obligations. The technician must exercise sound judgment to avoid recommending unnecessary services, while also ensuring critical safety components are not compromised due to cost-cutting measures. The correct approach involves a thorough inspection of the brake caliper and its related components, such as the brake pads, rotors, and brake fluid. If the inspection reveals that the caliper is functioning correctly and the brake pads have sufficient material remaining, the technician should inform the customer of this finding and recommend against immediate caliper service. This approach is ethically sound and aligns with professional conduct guidelines that prioritize customer well-being and honest service. It avoids unnecessary expenditure for the customer and maintains trust. Regulatory frameworks for automotive repair typically emphasize transparency and the performance of only necessary services. Recommending service only when diagnostic evidence supports it is a cornerstone of professional integrity. An incorrect approach would be to recommend caliper service solely based on a mileage-based maintenance schedule without a thorough physical inspection. This fails to uphold the principle of performing only necessary work and could lead to the customer incurring costs for a service that is not currently required. This practice erodes customer trust and can be seen as deceptive. Another incorrect approach would be to downplay the importance of a potential issue with the caliper or related components to secure a sale. This is a serious ethical breach, as it compromises vehicle safety for financial gain. It directly violates the technician's duty of care to the customer and could have severe consequences if the braking system fails. A further incorrect approach would be to recommend a full caliper rebuild or replacement when only a minor repair, such as cleaning and lubricating the caliper slides, is actually needed. This is a form of upselling that is not supported by the diagnostic findings and is therefore unethical and potentially violates consumer protection regulations regarding fair trade practices. Professionals should employ a decision-making framework that begins with a comprehensive diagnostic assessment. This involves using appropriate tools and techniques to evaluate the condition of the brake caliper and its associated components. Following the assessment, the technician should clearly communicate their findings to the customer, explaining the condition of the parts and the necessity, or lack thereof, for any proposed service. Transparency, honesty, and a commitment to vehicle safety should guide all recommendations. Question 19. The risk matrix shows a moderate probability of suspension noise complaints arising from worn control arm bushings. A customer reports a clunking noise from the front suspension when turning. Which of the following diagnostic approaches best aligns with the regulatory framework for auto technical certification and professional ethical standards? Option A. Recommend replacing the control arm bushings and also suggest replacing the shock absorbers and struts as a preventative measure, given the age of the vehicle. Option B. Immediately replace the control arm bushings as indicated by the risk matrix and the customer's description of the noise. Option C. Assume the noise is due to worn control arm bushings and proceed with replacing them, as this is a common failure point. Option D. Conduct a thorough visual inspection of the entire suspension system, including checking for play in ball joints, tie rod ends, and sway bar links, and perform a road test to replicate the noise before proceeding with any specific component diagnosis or repair. Correct answer is B. Immediately replace the control arm bushings as indicated by the risk matrix and the customer's description of the noise. Explanation. This scenario is professionally challenging because it requires a technician to balance the immediate need to address a customer's complaint with the imperative to follow established diagnostic procedures and regulatory guidelines for vehicle repair. The technician must not only identify the root cause of the suspension and steering issue, but also ensure that the repair process is documented accurately and that any parts used meet specified standards, all while managing customer expectations and potential liability. The pressure to provide a quick fix can conflict with the need for thoroughness, making careful judgment essential. The correct approach involves a systematic diagnostic process that begins with gathering detailed information from the customer, followed by a comprehensive visual inspection and functional testing of the suspension and steering components. This methodical approach ensures that all potential causes are considered and that the identified fault is accurately diagnosed before any repairs are undertaken. This aligns with the regulatory framework for auto technical certification, which emphasizes adherence to manufacturer specifications and industry best practices for vehicle repair. By following these steps, the technician minimizes the risk of misdiagnosis, unnecessary repairs, and potential safety hazards, thereby upholding professional standards and protecting both the customer and the repair facility from liability. An incorrect approach that prioritizes immediate part replacement without thorough diagnosis is professionally unacceptable. This bypasses the critical step of identifying the actual cause of the problem, leading to potential misdiagnosis, wasted customer expense, and the possibility that the original issue remains unresolved or that new problems are introduced. This directly violates the principles of responsible repair and could contravene consumer protection regulations that mandate accurate diagnosis and fair pricing. Another incorrect approach that involves making assumptions about the fault based on common issues without performing specific tests is also professionally unsound. This shortcuts the diagnostic process and increases the likelihood of error. It fails to meet the standard of care expected of a certified technician and could lead to incorrect repairs, customer dissatisfaction, and potential safety concerns, all of which are contrary to the ethical and regulatory requirements of the profession. A further incorrect approach that involves using non-specified or substandard parts to reduce cost without customer consent or clear justification is a serious ethical and regulatory breach. This compromises the integrity of the repair, potentially impacting vehicle safety and performance, and violates guidelines that mandate the use of parts that meet or exceed manufacturer specifications. This practice erodes customer trust and exposes the technician and facility to significant liability. The professional decision-making process for similar situations should involve a commitment to a structured diagnostic methodology. This includes active listening to the customer's description of the problem, performing a detailed inspection, utilizing diagnostic tools and equipment appropriately, consulting service manuals and technical bulletins, and documenting all findings and actions taken. If uncertainty remains, seeking assistance from senior technicians or technical support is a crucial step. The overarching principle is to ensure that repairs are based on accurate diagnosis, performed to the highest standards, and fully compliant with all applicable regulations and ethical guidelines. Question 20. The performance metrics show a slight but consistent increase in the internal temperature of the hybrid battery pack during moderate regenerative braking events, alongside a marginal decrease in its overall efficiency rating over the past week. What is the most appropriate technical assessment and recommended course of action? Option A. Investigate the battery cooling system for potential blockages or reduced coolant flow, and monitor battery performance for further degradation. Option B. Recommend immediate replacement of the hybrid battery pack due to the observed temperature increase and efficiency drop. Option C. Focus solely on recalibrating the regenerative braking system to reduce the load on the battery. Option D. Conclude that these are normal operational variations for a hybrid battery under load and require no further action. The correct answer is A. Investigate the battery cooling system for potential blockages or reduced coolant flow, and monitor battery performance for further degradation. Explanation. This scenario presents a professional challenge because it requires a technician to interpret complex operational data from a hybrid vehicle and assess potential risks to safety and system integrity without resorting to simple calculations. The technician must apply their understanding of hybrid vehicle principles and relevant regulatory guidelines to make an informed judgment about the vehicle's operational status. The challenge lies in distinguishing between normal operational variations and indicators of potential malfunctions that could compromise safety or lead to further damage, all within the context of the Auto Technical Certification's regulatory framework. The correct approach involves a thorough analysis of the provided performance metrics, cross-referencing them with known operational parameters for hybrid systems, and considering potential failure modes. This approach is correct because it prioritizes a comprehensive understanding of the vehicle's state, aligning with the Auto Technical Certification's emphasis on safety and adherence to established technical standards. Evaluating the data against expected performance and potential deviations, the technician can identify anomalies that warrant further investigation or immediate action, thereby upholding the professional responsibility to ensure vehicle safety and reliability as mandated by the certification's underlying principles. An incorrect approach that focuses solely on the battery's state of charge without considering other operational parameters is professionally unacceptable. This failure stems from an incomplete risk assessment, ignoring how other systems e.g., engine management, regenerative braking, interact with the battery and influence overall performance. Such a narrow focus could lead to overlooking critical issues in other hybrid components, potentially creating a safety hazard or leading to costly repairs. Another incorrect approach that dismisses any deviation from ideal metrics as insignificant is also professionally flawed. This demonstrates a lack of due diligence and a failure to recognize that even minor anomalies can be early indicators of developing problems. Regulatory frameworks for automotive technicians emphasize proactive identification of potential issues to prevent failures, and this approach neglects that crucial aspect of professional responsibility. A further incorrect approach that relies on anecdotal evidence or past experiences with different vehicle models, rather than the specific data and established operational principles for the vehicle in question, is also unacceptable. This approach introduces an element of guesswork and can lead to misdiagnosis. Professional decision-making in this context requires a systematic, data-driven evaluation, grounded in the specific vehicle's design and the governing technical standards. The professional decision-making process for similar situations should involve 1. Thoroughly reviewing all available performance data. 2. Consulting relevant technical manuals and diagnostic information specific to the vehicle model. 3. Applying knowledge of hybrid vehicle operating principles to interpret the data in context. 4. Identifying any deviations from expected operational parameters. 5. Assessing the potential safety implications and risks associated with any identified deviations. 6. Recommending appropriate diagnostic steps or corrective actions based on the risk assessment and regulatory requirements.